So folks, as Venky presents to us here today, you're probably gonna have questions maybe at the beginning, maybe in the middle, maybe in the end, or maybe after someone else asks a great question. At the bottom of your Zoom screen, you will see a Q&A box. So at any time, feel free to drop your questions in the Q&A box. Again, Q&A box, not chat, is the best place to drop it. All right, Venky, so I want to quickly just give you a quick intro. You've got an awesome background. So basically what you do is you aspire to enable engineering teams across all enterprise, spending most of their time in creating new business value rather than on various types of testing during the software development and development lifecycle. Prior to Mesh Dynamics, you were the co-founder of Elation, which created the data catalog product category. Very impressive. And then while at Google and at Microsoft Research, you initiated and you productized several projects. So Venky, I know you're super busy doing amazing work. Thank you for making the time to present to us today. I'm gonna go ahead real quick and mute myself and hand it over to you.
Thank you, Rosalie. Thanks for the nice introduction. This is one of my first times doing a talk over video. So if my energy saps and I'm putting you to sleep, somehow wake me up and I'll get out of the soft lull drone and actually use an energetic projecting voice as though it was a real audience. Anyway, I'm Venky Ganti, as Rosalie was mentioning. I'm going to talk about a few hurdles that we are commonly observing development teams trying to test and debug their microservices applications. And a couple of solutions which we believe are pretty useful for teams to adopt. So this is a slide that most of us from the development world understand. Microservices are here to stay. The adoption of these microservices has been increasing significantly for a variety of reasons. Not uncommon among them are scalability, ease of deployment, flexibility, and so on and so forth, plus the promised productivity and faster development. These are the promises that we are that are forcing a lot of people to go towards microservices, right? So that's one. And as we are talking to various people in this segment adopting microservices, we are also noticing a small fraction of them actually adopting microservices over streaming pipelines, whether it's Pulsar or Kafka. So here is a canonical example that we come across lots of times. So there's a UI talks to a REST service or to an order service. The order service puts a message on a topic like orders. Some other service picks it up, puts another topic on a different topic, message on a different topic, and so on and so forth. And ultimately, there are a bunch of notifications. The inventory service is updated. A bunch of other services are updated. And sometimes the notification or the UI itself is updated for the user to realize that their order has been placed and so on, right? So it's either real-time feedback to the user in some cases, or sort of a delayed feedback, depending on the application and the choice that the designers make. Now, in this scenario, if I'm a developer and the development team may be large and I'm only involved in developing the fraud service, if I'm making a change, fixing a bug, or making a change to my fraud service to enhance the functionality, I need to test it, right? Debug it and test it. So what's the typical process that we have seen or most of us follow? Yes, let's make the code changes. Let's run any unit tests that we have for that specific service, and maybe update the unit tests for my new changes. Now I need to test and debug the flow across other services. Is it working fine? Have I disturbed anything or not? My options are, can I deploy my branch to a shared dev cluster, instrument my service with logs and printfs and so on, dig through the logs to debug issues if there are any, and iterate and so on. If you're like me, I sort of have to iterate 3 or 4 times before I get the right log messages in my service. But if you're the smarter ones, you may get it in 1 or 2 shots, right? So the number of iterations that you have to go through to actually get the right set of logs and the right route to enable you to root cause, it's actually pretty painful if you're deploying your branch to a shared dev cluster and debugging and testing, right? The second issue here is, what is a set of traffic, test cases that I need to push against this dev branch, right? Where do I get the right set of test cases? Sometimes most of us cook up. It may be limited, may not be enough. And oftentimes that slips bugs through the system and will be discovered later in either an integration test run, if you're lucky. If not, it goes through to later stages, right? The other approach that we are seeing is the service level testing, where I mock all the dependencies, whether it's other services that I directly depend on or some other infrastructure that I depend on. I create the mocks. And so then I can test all my changes locally. But the challenge or the effort, the drudgery here is that I have to create these mocks. Most of us create a simple couple of stubbed mocks, and that's not usually enough. If you really are serious about service level testing, you need to develop a set of comprehensive mocks and maintain them as the software evolves, as the APIs evolve, and so on, right? So this is a significant amount of work. So I have to choose between a sort of a rock and a hard place here, and achieve my own debuggability within the IDE, right? If I need to use SL, service level testing. The other downside of actually deploying to a dev branch or a dev cluster, deploying my branch to a dev cluster and debugging is I cannot really use my IDE. I'm going through the logs to actually debug it, right? So that's a pretty significant downside of the first approach. Not to say also there's another downside here as if each developer wants a custom namespace to push their own branch, then the cost of the dev clusters starts shooting up, especially when you're talking about applications which have hundreds of microservices. Each of them wants their own custom namespace so that they can just push their own change along with some other versions of services that they depend on. The number of namespaces that you have to provision simultaneously is pretty significant, and the dev cluster spend on the AWS or Azure cost, whichever cluster you're on, is actually quite significant. Now, the second challenge, once I'm done with my unit tests and other testing across the flows, I now push over to the test automation side. Someone has to create the integration tests. It could be me or it could be a separate team, right? Then that particular engineer has to figure out, especially with this number of services increasing, it's not enough to just test the end-to-end flow right there. I need to design the test case such that I'm able to test the interaction among all the services as well pretty robustly. Each of us, fraud service may be making some assumptions in the way I'm consuming the topic, not just the contract. It could be some subtle assumption on the values, which may be violated by an upstream producer, or if I'm producing a message, I may be making subtle assumptions in there. All of those need to be tested well and in a full-fledged integration test scenario. And that involves a significant engineering effort there as well. So how do we enumerate and document all these test cases so that someone else, either a product manager or an engineer who understands all of this, has to document these test cases and spec them? Either a QE takes them up, first manually executes them to verify, prepares the test data, and then scripts them, and maintains this test and scripts through upgrades, right? So all of these are a significant amount of effort. Teams spend upwards of 25–30% of their time in creating these kinds of test scenarios and test cases. And that's a common occurrence that it's independent of whether you're building microservices applications over streaming pipelines or building microservices applications, which are synchronous, communicating synchronously. So these are all, this is a common problem, right? So all in all, the move to microservices, we expect high velocity from the development teams because we assume that now teams can move independently, and we should see a lot more productivity and people can make their choices independently and so on. One of the issues that we are seeing is the deployment tools, whether it's for scaling up, auto scaling, and so on and so forth, they have evolved quite maturely. And the deployment and operational tooling around microservices applications is evolving quite well, whereas the dev tools are lagging, right? If you go back to the problems that I discussed earlier, as a developer, if I'm changing one service, I need to test locally and test the flows across services. The two options that I have available are testing in a dev cluster, or take up service level. Sorry about that. Testing in a dev cluster or take up service level testing. So there's significant amount of effort that I have to put in to create these mocks and maintain them if I'm doing service level testing. So if I'm doing the testing in a dev cluster, I cannot really use IDEs, as I mentioned earlier. So both are pretty significant hurdles. And then the second problem is large engineering effort in creating this functional tests across the pipeline, right? So there's a demand for significant velocity, but there's friction from the lack of development tooling here. So together, this current approach is not amenable for achieving high velocity, right? So what's our solution? Our solution is, in a nutshell, putting in agents / listeners at various levels in your application, at various granularities in your application, whether it be at interfaces, could be function level for listeners for SDKs and so on. We listen to the API requests and responses between, let's say, the UI layer and the services themselves, or traffic between the services. And we capture what we call this usage data. Now, you can capture this data from any environment you please, whether it could be a test environment, a dev environment, or a staging environment, wherever you think the data is reasonably reliable to use, right? Especially continuous integration test runs or staging environments are a reasonably good candidate to get started. And we use that usage data to actually enable applications for the developers and the QE team to actually use to achieve the velocity they need to. Right? So the two common use cases, again, how do we create automated API tests easily without having to invest so much engineering effort, right? Here our solution is, once we capture the usage activity from some manual QA or ad hoc QA activity that's happening in your staging environments, we can actually automatically learn the API test from that. We'll walk through that particular flow. The second one is, how do you enable developers to test flows across services? Even if I'm making a change to my service locally, one service, how do I test that I haven't disturbed the flows across all the other services, right? So here again, we enable developers to test and debug locally from their IDE, right? And associated with them, the benefits for the first one, your engineering team does not have to invest effort in documenting the test cases, scripting them, and maintaining the test cases across the evolution of the application. And for the second use case, the benefits, first of all, is accelerated developer productivity. As a developer, I can test my change locally without having to worry about whether the services that I depend on, are they in the right versions? Are they available on the dev cluster right now that I want to use? I can use my IDE without having to put in a lot of logging and printf statements and so on, right? Yes, so I'll come to that. So the question is, how do you ensure or increase test coverage for test scenarios that we learn from usage, right? So the short answer is, we enable developers to add more test cases, especially negative test cases that may not be captured by other QA flows and so on, right? And that's the approach that we take. It will be clear maybe later in the later half of the talk. Okay, so again, drilling into the first use case, how do we generate API tests automatically from manual or ad hoc QA effort? So we put in these agents, we listen to the API traffic, the requests and responses at the gateway, between the services, from the service to some of the infrastructure layers. We capture this manual QA activity that is happening from the UI, whether it's in your QA actual manual QA engineers doing the test flows or a product manager running some smoke tests. Now they're able to look at the activity, and we automatically generate API regression tests based on that activity. And then we enable engineers or even the product managers to look at the test cases that were generated through our UI and edit them. And that's how they can also add more test cases. They can derive new test cases based on the activity that we already captured. And that's where you can enhance the coverage and so on. And when you have a new build that you want to test, let's say the next day, our Mesh Dynamics driver can actually replay part or all of the activity that was captured and compare the new output from this build with the baseline output that we generated from the activity that was recorded, right? So capturing the usage activity, let's say go back to our order management application. We put in a listener at the ingress service, the REST service. That's where we capture the API requests from the UI and the responses. And we put in listeners at the services that we need to validate, right? So we have a listener at this validator aggregator service that will actually record the activity that's being returned to the database. That's one listener. Similarly, the inventory service and the email service, let's say it's a SendGrid service. It's actually calling the REST API to SendGrid to send email. So we have listeners at that REST API endpoints, right? So all of these are being listened to. And when you have a new build that you want to test, the test driver can pick up, you can configure the test driver to pick up some or all of the activity and replay that activity to the UI or to the REST service, not to the UI, to the REST service. And then the flow goes through and we validate the output again at the listeners that we have at these three endpoints, the validator, aggregator, the inventory service, and so on. And the comparison is now between the actual that's coming out now on the right-hand side and the expected, right? And there are a bunch of requirements that we need this comparison to be to enable so that we can actually use it for testing. Let's dig into what those requirements are, right? So I'm looking at the actual and the expected output. First of all, as an engineer, I need to be able to quickly identify the places where there are changes, right? And review those changes. Once I review, I need to be able to act on those changes, whether it's a filing a bug or accepting the change and so on. And the second is application is evolving. I need to be able to update the expected output quickly, right? I don't have to be, so those are the three main requirements. And the way we achieve that is, so today, if you look at the test scripts, they're sort of combining three things: the script, the code that actually scripts the test, running the test, or calling an API with the input values, and comparing with the expected values, and the rules of the comparison, right? So I send an input request, I get a response, I'll take the expected response, I compare them all in one script typically. And what we do is actually, we split them apart. So there's a script that is taken care of by our driver. The expected and the actual data values are treated as data elements. The comparison rules are a separate entity by itself. All of these can be edited and operated upon independently. And that enables us to build the product in a way that the QE team or the engineer can then take on and say, oh, let me review what are the changes. How can I quickly identify the changes between the baseline data and the new data that I'm getting from the new build, right? The new actual data. And then I can act on them. Let me illustrate that with a few screenshots. So the visual comparison of changes are almost like a GitHub pull request review. So here is the expected data. These are the expected response for a particular API call that went through. And this is, let's say, one of the endpoints, the email endpoints, right? I'm getting this. This is expected, but in the actual, I'm missing that block, right? So I can quickly zoom in and say which requests are causing the changes. And and zoom in and understand why those changes are happening the way they are happening. And I can act on it and quickly say, okay, let me file a bug. I can file the bug. A bug is automatically populated. You can add whatever comments you want. And there's a URL back which provides the context, includes all the context of that bug. You don't have to waste time on documenting the context and the repro instructions for someone who's actually going to analyze and figure out how to fix or reject the bug, right? So all of this is automatically done. So if someone clicks the URL, they'll come right back to the specific place where the bug is filed from. And then it should be a one-click way of accepting a change. Suppose this block has been deleted and you know that it has been deleted. I don't expect it in my, I don't need to have it in my expected data moving forward from the next run onwards. I can click and say, update my golden, and this block is deleted. Similarly, you can click here and update the golden, and this new block is added into your expected data. So that way you've updated your data independently, right? So this is the advantage of splitting the test script from the data, the expected responses. And finally, yep, so that's accepting the change. So you can edit the expected data and comparisons via the UI itself. You don't have to actually edit it in any other editor. If you choose, you can, but everything can be done through the UI itself. So let's move on to the second use case. Again, recall, the goal is to enable developers to test flows across services without having to deploy a branch into a remote dev cluster or having to create an extensive set of mocks locally, right? And we want the developers to debug locally from their IDE and using all the IDE functionality that they have at their disposal. Modifying the fraud service, I need to be able to bring up fraud service, the changes I make them in my IDE. I want to be able to pick out a good, comprehensive, representative set of test requests, be able to drive these requests to my service in the IDE. And if I depend on other services directly or some Pulsar API calls, I need simulators for those. I don't need to be setting up those services either in a shared cluster or in my local box, bringing them up and keeping them up to date and so on, right? So this is the ideal experience we would like. Now, to enable that, what we do is we actually observe the requests and responses in your CI pipeline. So that way, or a staging environment, wherever you choose, where you believe you have a representative set of traffic going on, typically it tends to be the continuous integration pipelines which have the integration tests running. So we put in our listeners and filters into that CI pipeline. You capture the data continuously. Whenever the CI pipeline runs, we have the data, the requests and responses. So we enable the developer now to pick out a few requests to their service, a few or all of them, and these requests are consistent with their CI pipeline run. So there is an advantage to being able to test what the integration test pipeline is going to test after the code is submitted, right? So you actually discover those failures earlier and not have to wait until the CI pipeline fails later. So you have the test driver, you can pick that up, the set of requests, and these simulators and mocks are actually auto-created from the CI pipeline because these agents are listening to the set of requests that are outgoing from this fraud service, right? So all these mocks and simulators are auto-created. I don't need to invest any effort in creating those mocks. And these are much richer than any mocks that a developer would be able to create. We don't have the time to invest in creating that kind of extensive mocks. All these mocks are auto-created from your CI pipelines, right? So that's the big advantage. So, so going back to our example, so this agent here is actually listening in your CI pipeline, is actually listening to the calls that the fraud service is making to the orders topic and recording the requests and responses there. And when the fraud service publishes to another topic, it is recording the request and responses there, right? And this is a simple listener here. Similarly, there are different kinds of listeners. So the rest, all the requests and responses that are going back and forth on the REST interface there. And for JDBC, there are listeners, those different types of listeners, right? And this particular type of listener for Pulsar, for SDK, it's of this flavor. It takes a little bit of instrumentation in the code. So if you take any particular SDK API call, we create this wrapper. The wrapper first generates a consistent key for the specific call based on the arguments and so on, and the local thread context. Then if there's an intent, is the intent to record, or is the intent to not just pass through, or is the intent to mock, right? If the intent is to mock this particular call, then the mock service is actually called, and we pick out the response that needs to be sent for this particular key, the call for this call, and we both look at the corresponding the arguments as well as this key to find the best match in our in the repository, and respond to the best response that we can find. Oftentimes, the key is a good disambiguator. If there are multiple options for us, the key is useful to say, okay, there are 4 options. This is the particular option that I need to send. And then if it's intent to mock, this particular call is mocked by our mock service automatically. And if the intent is not to mock, then it flows through, makes the SDK API call. And if the intent is set to record, these args and responses are actually recorded into our recording service. And then it's useful, is available for mocking subsequently. So that, in a nutshell, is the second use case, how we enable the second use case. Pulling it all together, the instrumentation, we have to take any particular application, we have to instrument the app with filters, whether it's a REST filters or REST framework interceptors like Jersey or Spring Boot and so on. We have interceptors for those kinds of REST frameworks. And if it's SDKs and so on, we have to create those function wrappers. And then once these filters are created, we deploy the filters, capture the traffic from any environment you choose, whether it's a staging environment or a CI run or a continuous integration test run. We have the traffic from those environments. And now you can choose to run the tests for the automated API regression tests that were created from the staging environment, where a product manager or a manual QA engineer is actually testing some of the user flows. We can actually use the API regression test and adjust the comparison rules there. That's one of the first use cases that we discussed. And for the developer, all of these traffic that was recorded can be used to test locally from the IDE without having to create either a rich set of mocks or having to deploy in a dev cluster, right? So that is the overall flow. I think, that's about it. In a nutshell, basically, with all of these capabilities, we're able to increase dev velocity significantly. Developers are able to test and debug these microservices in their IDEs. They can prevent CI test failures even before they commit, because they're actually using the CI traffic. Then they're able to create and maintain API functional tests with little scripting, with no scripting effort. We're able to record from the manual QA or smoke testing activity and create these API tests and enhance them as needed. So that finishes my talk. You can reach me for any questions at venky.ganti@meshdynamics.io. I'm happy to respond. Please drop a note and say that you're reaching out to me from the Pulsar Summit.
Cool. So Venky, you are absolutely perfect on timing. It's 12 o'clock. We discussed at 12 o'clock we'd start Q&A. So you've got about 10 minutes before Simba joins us to present. I do see some questions in the Q&A box if you want to take a look there.
Oh yeah, sorry.
No worries. And folks, since we have 10 minutes, as we have time, if you want to add additional questions in the Q&A box for Venky, please go ahead and do so. You've got quite a few minutes, so thank you.
Yeah, so this is a good question from an anonymous attendee. Curious why you did not mention collecting usage data from production. Are you collecting test data or API usage data? So it's a very good question. You can deploy these agents in production. Only thing that you have to be careful is about obfuscating and encrypting sensitive data. There are some hooks in our agents to actually to do that. We have to configure the agents to say this particular field obfuscated or encrypted, and you can use it for subsequent replays. But the other challenge when collecting from production is that your data snapshots, when you replay, have to be consistent because otherwise you don't know whether the change is because of a data change or is it because of a logic change, right? There are some scenarios where we can actually simulate the data layer also, especially for JDBC traffic. Because of our agents, we have JDBC wrappers there. We can actually simulate the data behavior. So that way you can keep the data consistent between the capture time and the replay time. But we don't have those abilities for all kinds of data layers yet. So I hope that answers the question.
Okay, any other questions? All right, so we'll give it another minute here or so, Venky, and then we'll kind of wrap it up. But this was fantastic. Yeah.
Thank you. Yeah.
Awesome.
We got two good questions.
All right, go ahead. Yeah.
No, we got two good questions already.
Yeah. So. I also always like to check in the chat as well. Some of the questions have been coming in via chat, so I always check there.
I see. Where is the...
So checking, I think, no, I don't see any there. Okay, and yeah, for folks who are curious, yep, this was recorded, and yep, slides will be made available. So, Venky, I guess my only question is, can I clap for you? Is that okay?
Yeah, go ahead. Yeah.
Awesome. Because I know for my internal events, I always like to unmute everybody because folks love to clap, but since I can't do that on here, I'll do that. So thank you so much for this. I'm going to stop recording now, and thanks again.